Rytas ar diena jau. Bus toks trumpas pasisveikinimas lietuvių kalba dėl mūsų svečių iš Latvijos. Paskui persijungsim į anglų kalbą. Tai switching back to English now for our guests. So I'm Drs Pelenis, working as the EMC technology consultant for the Baltic countries. And today I'm both, a little bit sad and a little bit excited, actually, to be here. As I know, some of you may know that we are having our EMC World event starting next Monday already in Las Vegas. So tomorrow early morning, with some of you already flying there to States, and actually having really a lot of new products going there, new product launches and so on. Most of these I can't tell you today, I can't show you today, because they are NDA. So we have operator today, so if he's not leaking some information, maybe I'll give you some hints there. Actually, we're going to have the new Vplex announced there as well. So what I'm going to tell you today, on Monday, it will be most probably the history. So that's the sad part. The exciting part is actually that the product will be even more powerful, more flexible, and have more abilities and features. So that's the good point. So today, I'm not really going really deep there, as I told, we're going to have some new features there. So what can I promise is that after EMC World, we're going to have a series of events. It will be kind of EMC World update happening for the customers, both in all the Baltic countries, so Lithuania, Latvia, and Estonia as well. And after that, in the, I think it's August or September, we're going to have our EMC forum, most probably here or in another venue, where we're going to launch and to tell you about all the new products we're going to launch, let's say, next week. So that's going to be excited autumn for us. And just to start, as we really lacking time, we only have half an hour, so let's start with the Vplex and what it is, and it's really amazing technology. So the idea about distributing your data center is, again, the service levels are increasing. So when we talk about SLAs and when we talk about availability, mobility, and all these features, there are a lot of solutions, but there is no single one which is really integrated. So we have kind of these, general challenges and kind of benefits, what we can achieve here. So both availability, both utilization, actual mobility, and collaboration features with the Vplex solution. Well, it's more a bit of talk about the business continuity and disaster recovery scenarios and ways how we do these figures. But mainly it's actually, when we talk about RPO, RTO, recovery point objectives, how many data we can lose and how fast should we recover. There is, till now, I would say there was no single solution which could let you actually to do the instant restore or not even lose any data and make almost zero RPO and RTO. That's, with the Vplex, it's kind of enabled right now, and we can have already really high available data center with almost zero data loss and almost zero time to restore. That's nice slides. Actually, about the downtime, yesterday I had one event in one of the cities in Lithuania, actually talking with the guys about business continuity and disaster recovery scenarios. And I have another pie chart actually showing how many percentage actually the managed downtime is out in our daily operations. And that's actually about 80% of that. And there is so-called Boeing syndrome, which is like, once in a lifetime it can happen that the plane will really land on your data center and it will crash. And actually that's somewhere here, in these small numbers. So we talk about 80% of really unplanned downtime. And that's the place where we put a lot of our money. That's quite easy to handle. You just say, okay, the end users, Friday evening, starting at 10 p.m., we're starting our upgrades of the system. So no availability for you. That's quite okay. There will be one or two users maybe which want to use the resources at that time. But when we talk about some kind of, really disasters, we had one example several weeks before. Most probably heard that about the social media and so on. I mean, that's already the talk about business continuity disaster recovery. I can't name that. Maybe the customer is sitting somewhere here, so he may, punish me after that if I name it. So strategies for availability, I'm not really sticking to that due of the time, but mainly we can have the server part here, which is some kind of VMware fault tolerance and all these things. We can have the networking infrastructure with multi-pathing software. We can have like Symantec Veritas and all these solutions, host-based mirroring and so on. We have a storage infrastructure. Again, I mean, we can protect our data. The data will be in 2 data centers. I mean, the application will stay in the same data center after it crashes. So that's kind of tricky there. Power infrastructure and then site recovers. Again, I mean, good that we are living, maybe in Lithuania and the Baltics where we don't have earthquakes, tsunamis, and all these things, which really, I mean, helps us spend less. But I mean, these things can happen. Actually, to make the great return on investment, in this case, we created vPlex, and it was really, I mean, asked from our customers, how can we really protect the data? Not, I mean, building a lot of different silos. I mean, that's a server cluster, that's a storage cluster, that's a network cluster, that's a little bit of software, that's a little bit of hardware. Just make a single engine which can really give you business continuity and disaster recovery strategies there. So vPlex is actually, well, we're not telling it's more like a storage virtualization platform, but in general, yes, it is. So it's mainly hardware and software engine, which really helps you to have exactly the same information in 2 different locations and use that information. That's how it looks like. It will look brand new after 1 week. So again, some of the set points here. So it's really a distributed architecture. In this case, we have N+1 scaling and resiliency. So it really can scale out up to 8 engines, which is totally 16 controllers. 1 engine is 2 controllers. There, we're going to have it even more bigger next week also. So some of the bits and bytes I'm giving you. At the moment, we can sustain actually with the full rack configuration up to 200K IOs per this single system from one side, which is quite okay number. We're going to have maybe up to 3-4 times more next week again. So mainly it comes actually in 3 different packages. So-called, and mainly that's actually the software part. So the engines are the same, but we can have the vPlex local, which is actually for the single data center. We can have the vPlex Metro and vPlex Geo, which is really sounds something terrifying here. Synchronous replication through asynchronous distance. But really, I mean, this product works if we have one vPlex cluster node in Europe, another in United States. We can do synchronous replication between Europe and the United States. And the distance here is actually limited by the round-trip latence. That's the major key factor, actually, where we are limiting ourselves. So that's how fast we can get the IO response back from the secondary side. So what is unique, really, is actually that we have in 2 separate locations exactly the same data. I would like to tell, I mean, if you have data center here, we have 2 storage systems here, 2 servers here. Let's say we have 1 virtual volume, and both of our sites can write into the same volume. So meaning that's 1 disk which can handle 2-side read-write requests. That's quite unique. There is no single path, let's say in this case, so we are not traveling through 1 single site, let's say to the secondary site to pick up the data. We have exactly the same data in 2 different sites. So that's quite unique. So backend access data here is actually, we have the distributed volumes. Mainly it's the volume encapsulation. In this case, we can support both mirroring and concatenated RAIDs, so we can actually use whatever kind of storage array in the backend. We can use 1, we can use 10, we can use 20 of these. It all depends actually from, let's say, how many storage systems, how many legacy or new storage systems we have. There will be really new enhancements for that, including, let's say, snapshot technologies and all these things there. So just, again, short bit of what we're going to launch next week. Mainly, it's, I'm not sure, I mean, I think I have it in another slide, but let's say that's kind of the reads and writes serving. That's kind of animation. So it starts from the backend, it moves here, gets back. Same, simple approach. closed. We can move on. So that's actually the vPlex witness client, which is kind of the third side witness agent, which monitors the health of both vPlex sites. So we can place, let's say, that's primary data site, the secondary data site, that's a bunker site, or whatever. So you place this box somewhere in the bunker, which really, I mean, tracks how both sides are working. If the node is down, it usually brings all the operations down to the secondary node. The thing is that your hosts will never ever see any kind of errors with the vPlex. So I mean, if all the site is down and you're using, let's say, Oracle Rack, in this case, so Oracle Rack will not even shout about any single error, that the volume is lost or something like that. We also have the possibility, I mean, in general, that's actually, it stands in between, let's say, the storage. If we put the storage here, that's the SAN network, and that's our host. So it stands in between, but we can also have the so-called cross-cluster configuration, meaning that we can attach our servers not through the SAN to the vPlex, but directly to the secondary vPlex site. That's only available to now in some physical limits, so meaning the fiber channel length. Mainly it's in the data center limit. But in this case, we can even tolerate, let's say, the single SAN port failure, the SAN switch failure, the server failure itself, the single HBA failure, the storage failure, or full site failure. Usually it gets really expensive. I mean, as you really need a lot of ports to connect all the hosts to the vPlex. But you can mix and match this configuration. So applications and databases, actually, so availability, first of all, well, really support VMware, Microsoft, and Oracle. For sure, in these cases, we have quite big ecosystem of different applications which works. We actually have only this vendor. I can't say that today is kind of virtualization forum, but Microsoft is really supported up to the Geo. With the VMware, we're really working inside right now to tune a little bit VMFS to make it tolerate bigger latency. As right now, let's say with the VMware, we can only play with local and metro. As a VMware file system is not tolerating so huge, let's say, latency limits as can do Microsoft. So with the Geo configuration, most probably it's only Microsoft right now. We may have some new announcements also coming next week. That's some good saying for me now, kind of excuse. So we can have increased utilization here. We can use, let's say, the applications here. We can play with the mobility and availability of the data. So meaning that both sides can handle the applications here. We have this data here in the vPlex nodes clustered, so everything is kind of synced in the backend. So meaning that all the availability scenarios are truly available and easily done without even, let's say, some kind of native technologies there. That's animation to show, so the site is done. We move everything to the secondary cluster as the data is already there. So it's only about moving the application to the secondary side, nothing else. Also for Oracle Rack with the vPlex, we have tested that in our own EMC data center. And we're using vPlex for our Oracle, as most of the EMC internal applications are actually Oracle e-business suite, Oracle database based. So we are using vPlex actually to ensure the availability in the United States between two of our data centers, which is one located in the East Coast, secondary in the West Coast. So with the Oracle Rack, actually what we do here is we can totally tolerate full data center disaster, not even losing single connection to the application. What we do, let's say, see there is only, let's say, some decrease in transactions per second because of the Oracle Racker build times, but it lasts like 1 minute or something like that, and it's get up again. So all the connections are still handled fully by the cluster, by the rack, and actually we can lose single data center with no problems there. Again, because of really the 30 minutes for this session, I cannot show you one demo, but you can easily find that on EMC demo resources. So vPlex extended Oracle Rack, put that on Google. You're going to see the video there. And actually, it really shows how it works there. It's done internally in our data center. So it's something like 15 or 20 minutes movie. So you can see how it works really in management console and all these things and how easy it's rebuilt. That's again some kind of animation. Also, that's kind of, again, we're a kind of small country. I don't know if any of you have, let's say, some really big collaboration issues, let's say, sharing the data with partners, and I don't know, in China or States or other European countries. But let's say, in this case, what we have with the metro, it's kind of data across sites. We used Vplex in Beijing Olympic Games, actually, so BBC and NBC, the televisions, when they were recording, let's say, the Olympic game videos, they were directly putting the information onto the virtual volumes. And these volumes were stretched through one Vplex node standing in China, another in UK and US. So these guys put there the data, and actually already the operators, or the ones who are broadcasting the signal, they could start to stream it directly to the TV channels. So that's kind of a collaboration approach in this case. So there is no need to use FTP sites or something like that, so you just start to place the file and you can read it already. Okay, not even to putting it full. So that's kind of, for more, let's say, geographically dispersed locations scenario, but it's also possible to do it with that. Live migration, well, as I told, with the VMware it's up to only to the Metro. With the Hyper-V we can do that on Metro and Geo as well. So that's mainly the backside of the VMFS, as I mentioned. So when we really, see that's kind of more disaster avoidance scenario, or let's say if you really need to do the tech refresh or something like that, so you just place 2 Vplex cluster nodes there. You virtualize all your backend storage, let's say it may be legacy storage or something like that. You encapsulate all the LANs, it's really transparent for the host in this case, and you just move all your workload applications to the new data center. That's quite easy. The data is in both sides, so all you have to move the application and users mainly to the secondary data side. So there is no so-called replication or something like that. The data still from the host side, it will look like one single disk. So there is no need for you, to mount the new disks, to map them, and so on. You have one single disk actually for the both sides. You move that data in and out as you like. So you see increased utilization, or you need really some free space for, let's say, I don't know, some kind of project to go. You just take it, everything, move there and back. Quite easy. Resiliency, failure scenarios with the cluster storage and ISL links here. So that's continuous availability again. There's some kind of, we have ISL of man. We have several of these actually already built in cases. So that's improved utilization. We have operating costs. The easiest part with the Vplex is that, you're really reducing your amount needed to provision the storage. So you don't need to, let's say, to map each single LAN. You don't need to create all these kind of resiliency scenarios, to mirror the LANs, to make concatenated rates and so on. All you do, you have one single ID for one virtual wall, which in the backend it may span into 1, 2, 3, 4, whatever storage systems there, and you really present for the host only one. So then you can play with the utilization levels here. If you have, let's say, more faster storage on the primary side and then, let's say, a little bit slower storage on the secondary side, you can also do these play tricks with, let's say, kind of SLA levels. So you have the application which really requires, let's say, some performance, so you leave it here, but some kind of applications you can easily move to the secondary side. Maybe it's end of month and you do some kind of data warehouse to produce reports and analytics. You really need some kind of I/O from the backend array. So you just move everything which is not really loaded at that time to the secondary side. You do that and move the workload back. So that's how you can really, do the utilization part on the storage system. You can fill the storage up to 80 or 90% even. Virtualization within data center. Mobility, again the same kind of scenario. Let's say with the VMware we really have a nice scenario so-called stretched VMFS cluster. So the meaning is that, let's say right now if you create the VMware environments in your data centers, what you do, you create the LANs, then you create the data stores, yeah? And then you, on top of that, you start to put the, let's say, virtual machine. Then on the secondary side, you create the same data store, let's say, or 2 data stores or 3 data stores there, and also create the virtual machines there. So what you can do with that Vplex, in this case, is actually you create one big virtual wall, and you create one single data store. You put all your virtual machines there. And you have one file system which is spread across 2 data centers. There is no any more so-called vMotion, storage motion, storage DRS, and so on. You have one single file system which is already in 2 data centers. Also, some bits and bytes from the next week. Yes?
Last question. So if you have like synchronous replication, do they add additional latency to virtual machines on this volume?
And yes and no. Let's say it's up to only to the Metro. Metro can sustain only 5 millisecond round trip latency. So meaning that's around up to 100 kilometers, not more, in general. I mean, if it's dark fiber with not lot of switching and so on, you can really have this kind of latency. We really do some investigations with the VMware right now. As you know, VMware is a company which belongs to EMC. And we're really trying to push the limits a little bit further in the VMFS, so it can really, I mean, start to work a little bit faster, or tolerate, let's say, higher latencies in this case. Then we can really move these to the geo distances. Right now, up to Metro, I mean, Lithuania is quite small. So 100 kilometers is, I don't know, Vilnius. It's possible to do that. And it's not the kilometers itself, it's actually the latency. So if you really have great latency here, you can really put that VMFS stretch cluster. 5 milliseconds is not so much in that case. Also, I mean, engine internal, what it has, it's Intel based. It's kind of, you know, as our CEO and vice president of EMC, you know, most probably will talk next week, is that EMC became kind of, you know, the software company, so-called. Most of our products are really based on the software solutions, which are bounded then on top of standard x86 servers. Vplex is actually, if to look internally, is only x86 server. That's really standard Intel-based x86 server. So all the functionality there is really done by software. So meaning, I mean, each time when what we see in our storage platform, when we put, let's say, new storage technologies, not storage, server technologies there from Intel, let's say we're going to have the Ivy Bridge already support on our storage platforms, and we tested that with Ivy Bridge CPUs. I mean, the performance there increased like 4 times. Most of the products are really dependent on the CPU cycle. So how fast we can calculate the data. Then there goes like DRAM. So if we have the DRAM in Vplex, we actually have it coherent. So each time what we do is really check the bits and bytes in both DRAMs, in both engines, and see if they are the same. So most of the information is really being communicated and say synced between the engines itself, not the backend storage. So it's quite fast. It's not like you do the sync replication between the storage arrays and then you just present it back to the host. So in this case, you have all the routes. So server, LAN, SAN switches, storage, communication all around. It's the same 5 milliseconds for sure, usually. I mean, it's a little bit one layer higher. So we don't need to calculate each of the single IOs. Most of them are really in RAM. So it's more so-called cache gives in this case. It really has the same as the storage technology, some of the basic features there, how it works internally. Just the backend is a little bit different. So I mean, that's really a good scenario in this case. I mean, let's say if you have the same stretch cluster, I mean, it's really to manage it. We're going to have also, so not sure I can tell this, but let's say the ability, if you saw the vSphere 5, there's so-called DRS, Distributed Resource Scheduler. So that's, let's say, the integration through the VMware and VII and VASA integration through these APIs. Actually, VMware can now see, let's say, what is really in the backend of the storage arrays. Before it was only like the disk. So when you now see what is really in the backend, so with the Vplex, I can create, let's say, one wall, or I can create 2 of these walls, and name one, let's say, that's gold, that's bronze. So DRS, based on, let's say, affinity rules, will move these workloads between virtual walls. But that's not in the storage array. That's actually in the RAM wall. So that's happening more fast. how much I'm doing with time. Okay. So that's exactly about, let's say, in the heterogeneous environment, so meaning that it can be like, I don't know, HP, EMC, IBM, EMC, Hitachi, whatever storage systems you have. You can have the same with the legacy system. So move these workloads between the different assets you have already in the data center. So kind of just-in-time buying approach. That's again a lot of animations to show. Too bad we're really lacking time, but I mean, if some of you are really interested, we can do this in some kind of break, the demo. I can show you how it works in ages. That's kind of mirroring, common host-based scenarios, then active, passive. There is one technology in EMC, so-called Recoverpoint. You have heard such, so it's also kind of in external appliances used for synchronous and asynchronous replication between two sites. Recoverpoint is unique that it has the journal internally. So each I/O operation which comes to the journal is mapped there. So I mean, when you start, let's say, the usual, I don't know, Friday, let's say, activity for your data center is like patching. So you have pre-patch, pre-fetching, then patching, testing, validating, and so on. So I mean, if you really, in some cases, let's say, break a data center, so you can restore just a single step back. With the vPlex and the Recoverpoint, also next week, we're going to have integration with these two products, meaning that we can have, let's say, active with the vPlex, also with disaster recovery. We can have the step-by-step journal-based approach, sync the data to the secondary site, let's say, only using the Recoverpoint on this side. So that's, let's say, it's here with the round trip latency. You see the numbers, different ones. So I mean, right now we can do relay. I mean, if you have one data center in Vilnius, one in Kaunas, and you want to place one in Klaipėda, let's say, which is really more than 100 kilometers, and let's say the latency is quite higher. So what we can do here, so we put one vPlex node here, one vPlex node here, and then we can really do, let's say, to the disaster recovery site with the Recoverpoint, maybe async replication, or the same, it depends on the distance really. But it can be async, so still having, let's say, all the information for, in case of corruption, because usually if you have synchronous replication and corrupted data, what you do, you sync the corrupted data to the secondary data center. That's simple. How to prevent this? I mean, putting that in the journal level. So vPlex will have these so-called Recoverpoint splitters built in also next week. So meaning that both with the vPlex, not only, I mean, virtualizing the volume itself, but also keeping the track of all single IOs, what happened there, plus to make it aware of application. As Recoverpoint right now it does that. So we have so-called replication manager software, which really knows what kind of application. Is it Oracle, Microsoft, VMware, SAP, or whatever. So it really knows that that's Oracle, that's happening, okay, we're writing the database, and that's crash. Okay, let's recover back to this last write, which was okay. And that's kind of summary benefits is actually that in general we can do the load balancing, we can do the federation between sites, and that's not like simple mirroring approach, so we're not just mirroring the data. I mean, we can really move it easily, as it's already in the two places. The second thing which really, I mean, unique is that it still has access from both sides of the same data. If you take all the industry approaches right now, we have several solutions close to this one. They all do, most of them actually, I think there's only one which does quite similar. They do that through the single site. So meaning that you always have like one active and one passive. The data is still on both sides, but it's not easily transferred. And that's it. That's the 30 minutes. Not exactly the best time to do and call about this technology talk, but let's say that's kind of, you know, general overview. As I promised you, I don't know when, maybe a month or two, most of you will get the invitations, but we're going to have that kind of EMC World Update Tour event. Here we can have way more technical sessions there, getting deeper into most of the products. We're going to have a new high-end platform update. I don't know, most of you, I don't know, maybe know symmetrics, but we're going to have the new symmetrics, something like 4 petabytes, big box. A lot of 100,000 of IOs there. We're also going to have so-called VMAX for service providers, built-in package storage already there, with a lot of nice metering, chargeback, functionalities, reporting, and so on. That's already the storage platform. A lot of fancy things going. So, we're finished. I think Thomas should start now with the free part.